What is the smallest positive value of x that would make the following true? Now here, I mean, a direct translation from the identity would be helpful. I mean, for this because, but you again, the cosine of x plus pi, you could kind of figure out on your own because you say, okay, well, if I take an angle x and I move 180 degrees, it's going to put me into a quadrant where the cosine is going to be the exact same sign as the previous one. Okay, plus pi. Plus 2 pi. No, it's plus pi. It's going to be opposite of what it previously was. So if I'm in quadrant 1 and I move 180 degrees, I'm going to be in quadrant 3. Cosine is going to be the opposite side. If I'm in quadrant 2, cosines are negative. I move 180 degrees, puts me in quadrant 4 where cosines are positive. If I keep going in that kind of general idea, it's going to be the same irregardless. So I know that the cosine of x plus pi is the same thing as a negative cosine x. So substitute, I can say negative cosine x minus cosine x equals 1. That would give me negative 2 times the cosine of x equals 1, which means the cosine of x would be a negative 1 half. Now comes the question again. We're going to start getting more into this as we get into chapters 5 and 6, where we start solving trigonometric equations. Because I'm looking to solve this equation for x, but we're going to learn that well, there's an infinite number of angles that if I take its cosine will give me negative 1 half. Because the fact that if I just if I find one just alone moving 360 degrees from that angle is going to give me yet another angle that's going to work because it's coterminal. Not only that, there's two different quadrants where angles could produce a negative cosine and therefore produce a negative 1 half as a cosine, and therefore I would have 360 degree movements from each one of those. So there's an infinite number of angles that would produce a negative 1 half for x. I'm looking for the smallest positive value though. So I kind of go back to my idea behind I know that the reference angle seen in 1 half is going to be pi over 3. So I'm looking for an angle that has a reference angle of pi over 3. It gives me negative 1 half as a cosine. The smallest positive angle would be in quadrant 2, because in quadrant 1, if I start in standard position, start moving, I move through quadrant 1, cosines are positive. I get to quadrant 2, that's where the cosines first become negative. So it's going to be a quadrant 2 angle that has a reference angle of pi over 3. And the angle that does that would be 2 pi over 3. Is that the only angle? No. There's other, 4 pi over 3 would also be an angle that has a negative 1 half as a cosine, but it's not the smallest positive one. I could produce a whole bunch of other ones by adding 2 pi to those values, to 2 pi or 2 pi over 3 or 4 pi over 3, but again, they're not the smallest. I can subtract 2 pi from 2 pi over 3, but then I have a negative angle. It would still have a cosine of negative 1 half. So as I said, there's an infinite number of answers here, but the reason why we get this as the answer is because we were asked for the smallest positive value. Now, example 23 here. This one requires a lot of abstract thought. It's not an easy problem, but there's one like this on WebWork, and this is why I'm going through this. You're told that the sine of A equals negative 0.3 and that the tangent of B equals 2. We want to find, with A and B both in the interval from pi to 3 pi over 2. So basically, angles A and B are in quadrant 3. Okay. We want to find the exact values for the following. I'm going to kind of draw where the sine of it, where A is going to be. Angle A would be in the third quadrant, as we said. There's its reference angle. Negative 0.3 is the same thing as saying negative 3 over 10. So I'm drawing it as such, and I'm going to calculate what the x value would be for that, which would be the negative square root of 91. For B, same kind of thing. The reference angle for B is, I'm showing that. I'm not going to find out what that actually is. But we're told here that the tangent of B is 2. Now, it's going to be negative 2 over negative 1 because that's why it ends up being positive, because my x and y values are negative, both of them, and a negative divided by a negative is a positive. So, and I calculate what the hypotenuse is. Square root of 5. When I looked to do the cosine of B, Okay, so I see where B is. That one's going to be pretty easy. Okay, because when I look at there, well, the cosine of B, I'm looking at that reference triangle down there. I'm just going to look at that triangle down there, which is a right triangle. I didn't draw a little right angle symbol in there, but I'm just going to do x over r and get negative 1 over the square root of 5. For some reason, the cosine B is not showing up really well there, which I could also write as negative square root 5 over 5. And for B, the tangent of negative a. Now there's where it gets a little tricky. I see where a is, but if I do negative a, that means I went in the opposite direction, moving 3 quadrants, moving into a third quadrant, which means it's going to put me in quadrant 2. In quadrant 2, you know, the tangent's going to be negative. So when I look at quadrant, I mean, if I did quadrant 3 here, I'd have negative 3 over negative square root 91, or 3 over the square root of 91. Up here, it's going to be negative 3 over the square root of 91. So the tangent of a would be this. That means negative a would have to be this. And again, if I wanted to rationalize that, I would have this as the rationalized answer.